Okay, now today we're gonna work on the very last experiment, lab number 7. This is a combination of series and parallel circuit. Okay, so we're gonna need 4 resistors for today, listed in here. Today's lab is actually not very complicated, but it does need you to fully understand what we have covered during the lecture, because especially when you do the computation, trying to figure out the current through and voltage across each resistor in the combination circuit is going to be a little bit complicated. But as long as you fully understand what we talked about during the lecture, it should not be a problem. And also after today's lab, you should be able to get a much better understanding of the course content that we covered during the lecture. Okay, so again, table 1 is still going to be double check or to check the measured value of each resistor we're going to use for today. Okay, and for this two in here, we're going to actually draw the equivalent circuit. For example, this one, in step 3, we're going to draw the equivalent circuit of figure 2 of the circuit shown in figure 2 by combining those two resistors together. And for the next one is we're going to draw the equivalent for this one. Step number 10, we're going to draw the equivalent circuit of this figure of the circuit shown in figure 3 by combining this two together and this two together. Okay, and then we're going to actually fill in those two tables by doing a bunch of computation and the measurements. Okay, first of all, I would like to show you how to construct the circuit shown in figure 2. Okay, this time we have to make sure that our Vs here is 12 volts, and we need R1 2.2K, 2.2K, okay. So the current, we need to connect from the positive to the 2.2K. So positive to the 2.2K. That's line 2, okay, line 2. Positive to 2.2K. 2.2 goes to R2, which is 4.7. Okay, 4.7. This is still, they are connected in like this, okay? So we'll just leave the thing alone. We're gonna come to that later on. So this thing goes to here, and then it goes to, R2 goes to R4, which is 10K. I'll move it down a little bit so that it's easier for me to hook up the circuit. Okay, so positives go through R1 and then R2 and then R4. Okay, R4 is 10K. Okay. Put it like this. Okay, see, they're in the same line. And R4 goes back to the power supply or the ground. Okay. Okay, goes to the ground. Oh, see, this one, yeah, I made a mistake. So here, R1, R2, R1, R2, and R4 are all connected in together in series. So this one actually should be R1, R2, and R4. Okay, should be on this side. Yeah, that looks much better. And then R4 goes back to the negative terminal or the ground. Okay, of your power supply. Okay, and then we need to have R3 in parallel with R2. So R3 is 5.6. Okay, the thing is going to be in parallel with R2. This is R2, okay? Okay, in parallel with it. Okay, now it's in parallel. Okay, so this is how we hook up the circuit over here. That's your figure 2. So the way we redraw step number 3 over here, first of all, you need to read what is step number 3. Okay, so after that, what we are trying to do is to draw the equivalent circuit of this one in here by combining those two resistors together. We give it a name for the equivalent resistor of 2 and 3 combined. It's called R23. Okay, so the circuit would be something like this. You see it? Okay. We used to have another resistor in here, but we combine those two together. So R2 plus R3 is our R23. The here R2 plus doesn't mean we are going to add those two together because they are connected in parallel. Oh, I think it's better for me to put it like this way. Okay, it's R2 in parallel with R3, R2, R3 combined. Okay, so that's why this is the equivalent circuit. Okay, and for table 2, we just need to do a bunch of measurements and the computation. And for computation, you need to make sure that we're using 2 different kind of approaches. The first one is using the voltage divider, and second one is by using the Ohm's law. But when it comes to the total resistance RT, basically there's no difference. So the RT is just okay. RT is, because what we have now is a series circuit, right? Series circuit. So R1 plus R23 plus R4. So R1 plus R2 and R3 in parallel plus R4 is going to be your RT. So you're going to put that computed number in these 2 blanks over here. And V1 is going to be the I total. The I total is going to be the VS divided by R total. The R total is the one you just computed, okay? And V1 is, if you're using the voltage divider, then your V1 equals R1 divided by R total times your VS, okay? And if you're using the Ohm's law to compute V1, then you're gonna use V1 equals R1 times I total, the total current. This is the Ohm's law, this is the voltage divider. And you basically apply the same rule to the other 2 resistors to compute V23 and V4. And for I2 and I3, I2, I3, and I total, oh, they're not equal. I2 and I3. Okay. I2 in this case, we need to go back to this circuit, the original circuit. I2 is the current through the R2. So it's actually V23 divided by R2. Okay. And I3 is V23 divided by R3, okay? So if you're looking for like what is the current inside of the combination circuit, the combination resistor, you need to go back to the original circuit to figure it out. So I2, so the voltage across R2 and R3 is the same because they are connected in parallel, and that's the voltage across your R23, so it's V23. So the voltage across R2 and R3 is your V23. So that's why we're using this method to compute the current through each resistor, okay? And you can see they are listed under the Ohm's law. So we can only use Ohm's law to compute the current through R2 and R3, which is I2 and I3 in here, okay? So that's table 2. And for table 3, first of all, we need to do the step number 10. Step number 10 is we need to redraw the circuits shown in figure 3, okay? And to do that, the equivalent circuit for this one is going to be combining R2 and R3, R1, R2 together, and R3 and R4 together. So they will get a circuit like this. So when you combine R1 and R2, we have R1 plus R2 in here to form a resistor called R12. And if you combine R3 and R4 together, we have a new resistor or new equivalent resistor called R34. And the value for that is going to be R4 and R3 plus R4 because they're connected in series, okay? So that's the, so this is the circuit for step number 10, okay? And for the last table in here, this is also very easy. Again, you need to follow the procedures in here so you will be able to know how to compute them, okay? But basically, R12 is just R1 plus R2. R12 is R1 plus R2, and R34 is R3 plus R4 because they are connected in series. So you just add up those two numbers together. And R total is going to be those two resistors in parallel, like these two resistors in parallel. So that's why you have R12 times R23, R12 times R34 divided by R12 plus R34, okay? So you need to make sure you're using this equation in here. And I total, still you're using the same way. I total is Vs divided by R total. I12 is Vs divided by R12, okay? This is very simple. I34 is just Vs divided by R34. And for each voltage, the voltage across each resistor, we can use voltage divider because for example, in here, we know the total voltage across R1 and R2 is your Vs. Then by using the voltage divider, it's very easy for us to figure out like the voltage across each resistor. So for V1, it's R1 divided by R1 plus R2 times your Vs. And V2 is just R2 divided by R1 plus R2 times your Vs. And the same thing goes with your R3 and R4, okay? V3 is R3 divided by R3 plus R4 times Vs, and your V4 is R4 divided by R3 plus R4 times your Vs. Okay, so this is very easy to complete. Okay. Okay. Now I'm gonna show you how we can hook up the circuit of figure 3 so that you will be able to do the measurements. Okay. Let me remove the thing. Okay. The first resistor we're using is, we have R1 and R2, which is 2.2 and 4.7. 2.2 and 4.7. This is 4.7. Okay. 2.2, 4.7. So the current comes from Vs, goes into 2.2, and then 2.2 to 4.7. Okay, 4.7. And then goes back to the and then goes back to here, the ground, which is the line number 4. Okay, so that's it. And then from here, it's gonna split in 2 ways. So this one, R3, is also connecting to the positive of your power supply. So R3 is 4.7, 5.6. 5.6, where is 4? 5.6. Okay, so this one from the positive to here, okay, to here, and then go through your 10K ohm. In here. Positive to 5.6, 5.6 to 10K ohm. Okay, and then the 10K ohm will go back to the ground. Okay. Okay, that's the ground. Okay, so that's basically your figure 3. So after you have hooked up the circuit, then you will be able to do the measurements of all these resistors, voltages, and we cannot do current, so we just ignore that part. One thing I would like to mention in here, you have R1, R2 computed, you have no problem for that, but if you want to measure that, you have to make sure the R1 and R2 are completely isolated from the rest of the circuit, okay? Just like what we have done for lab 6, okay? So that's actually very simple, but you have a lot of, not a lot of, just a little bit more calculations and measurements to do, but in the overall is actually not that bad. So please take your time and make sure you don't have, any, errors when you're trying to compute those kind of currents and voltages, okay? Make sure you understand the meaning of the subscript. For example, V1 means actually the voltage across R1, and I1 means the current through R1. The IT is the current through the entire circuit, or the total current, and VT is just Vs, right? And RT is the total resistance. And please note that the total resistance does not always mean the sum of all the resistors together. Because, for example, if you have several resistors connected in parallel, like what we have done in lab 6, then the way you compute the total resistance is not just adding up all the 4 resistance, okay? So it's gonna be a little bit different. So if you are okay with that, then you shouldn't have any problem for this lab, okay? I think that will be it, okay? Make sure that you finish the questions, the review questions, and then include that in your lab report, okay? Again, make sure that you have your lab report, combine all your files into one single PDF and upload that through the Blackboard, okay? Thank you.